All right, so picking up where we stopped on the last one, we are still in 1.7. We're on letter D. Is this as far as we got? I feel like I was like yelling at the end of the class, and I was like, "What is inscribed?" And you were like, "It's around or inside, whatever." So I wanted to kind of focus on that vocabulary. So if we looked at 18, we said the word inscribed means that it's inside. And then another word that we might know is the word circumscribed, which means it's about, it's around, it's on the outside. So we've got this square inside of a circle, and it says write the area of the square as a function of the radius of the circle. So we have to write the area of the square using r as radius. My first question to you is, what is the area of a square?
Pi.
What?
Pi r squared.
No, of a square.
Oh, like
Sure. Or in a square, what do we know about all the sides? They're equal. So we could just call it s squared. Length times width. But this is going to make more sense in a second. So think about all the sides are congruent. They're all the same. Okay. Now, we got to get r in here somewhere. So r is what? What is r? No, what is r? What is the radius? Radius. Where is radius in my circle? From what to what? You guys are all like doing little line things to me.
It's like across the circle.
The whole distance across the circle?
No, it's half.
It's from the center to any point outside the circle, right? So what I'm arguing is that I could draw the radius in a couple different places, and there's only certain places where it would be the most helpful. So like technically, is this a radius?
Yeah.
Yeah, is that a helpful radius?
No.
Not really, because it's got some piece outside of the square. Is this a radius?
no.
Yes.
Yeah, is he helpful?
Yes.
Yeah, I
Very
think he's helpful. Actually, very helpful. I'm gonna draw one more radius over here. What do you think about him? Is he still a radius?
Yes, ma'am.
Do we see why I think those two are more helpful than the first one?
Yes.
Why, Zach?
Squared.
It goes all the way through the square and the circle. When it goes like in between, it's not that helpful to me, but I wanted to have points that touch both the square and the circle, and both of those do it. So we're gonna call those both R. Now, what I've got here is I need us to remember a little bit from geometry, which I know is a big ask, but I've got a little right triangle down here. Do you remember the special right triangles where we have two legs that are congruent to each other? Remember what those were called?
Wait, can you say it one more time?
It is isosceles. It's an isosceles right triangle. I've got a little right triangle here. I've got a special right triangle where the sides are the same. Ryan, what are you thinking?
So like 45,
45, 45, 90. So I've got little 45, 45, 90 degree triangles down here, okay? Both of my legs are R, and then there's a pattern that tells me what my hypotenuse length is. Andrew?
Is it R2?
R root 2, amazing. No one in my last class remembered that. That's awesome. R root 2. I am going to expect us to know that later on. Chapter 4 is trig. We're going to review these special right triangles. I'll reteach that to you then. But Andrew, I'm so glad you remembered that. So I've got like a little right triangle going on here. I've got, these sides are both R, and this side is R root 2. Now, I already labeled that side as what? A little s. That's the same thing as s. So the reason we wanted to look at it this way is I don't want s in my area. I want to use r. So instead of s, what can I write? Just r? R root 2. All of those little sides of the square are R root 2. So my area is going to be R root 2 squared. Area of that rectangle is the same thing as R root 2 squared. And we could square that. We could square R. We could square R root 2. Area equals 2R squared. And I don't know what my units is. It'll be units squared. So that's how we kind of used both shapes. We found different variables we were able to solve and get area in terms of R, not S. Okay. I'd like to come back and do it one or two more on this set later, but I want to go down and do one more problem that I think is super important. So I told you the box problem is super important. It will be on your test. These next problems, I'm going down to G and H to do 28, or sorry, not G and H and I to do 31 and 32. These are definitely on your test too. These are what we call mixture problems, okay? So we're gonna do mixture problems. So let me zoom in so you can see what problems I'm looking at, okay? So if anyone wants to take a picture, now's a good time. If not, you can pause the video, write any of it down. You're a student, you can do what you want. What's going on here is we're mixing two solutions together. We're playing a little chem lab. So essentially I've got like a cup or a vial or a beaker of something, and then another cup or vial or beaker of something else, and I'm gonna pour them together to form one new combined solution. Every time I do this, I set up 3 little boxes so I know what all my measurements are, what all my solutions are. Kind of like this, how it has like little cans. I just do like a much less intricate version. I just do like a little box plus a little box, and that's going to equal another little box. In all 3 boxes, we're going to have a percentage of the solution, and we're going to have an amount, or in terms of like gallons or liters or ounces or whatever they give us. Let's go with a percentage first. The problem says how much 10% solution and how much 45% solution should be mixed together to make 100 gallons of 25% solution. What's my percent that I want to end on? What do I want to finish with?
25%.
25%. So I'm going to write 25% in my last box. And then I'm going to write the other 2 in either of the other 2 boxes. They're being added. It doesn't matter which order. I'll go smallest, 10% to larger, 35%. Those are my percentages. Everybody good with that so far?
That's 45%.
Oh, sorry, 45. Is that why I saw some confused faces out there?
Yeah.
I try to remember them so I don't have to keep scrolling back and forth to like jump around on you guys, but then I remember wrong and then you guys look confused back at me and I'm like I didn't think there'd be questions yet. Okay, the harder one is the amount. I don't think it's that hard, but it is harder between these 2 because you have to decide what the amount is. So this one says that we are mixing together a 10%, some amount of a 10%, some amount of a 45%, and we're going to get 100 gallons of the 25%. I know how much I'm going to end with. I'm going to put 100 gallons in here because that's the amount I'm going to end with. These 2 boxes need to add up together to make 100, okay? One of them is just going to be X. As tempted as you are for the next one to be Y, do not make it another variable. We want it in terms of X. So if I have X plus something equals 100, does anyone know what will go in my second box? What if I said that I had 20 gallons of the first one? How much would I have of the second one? 80? How'd you get 80?
It's 100 minus 20.
Good. If I did 100 minus 20 to get 80, what do you think I'm going to write in this box? 100 minus X. Very good. It's kind of yucky to write it like that, but that is truly what the expression is. It's 100 minus X. I'm going to take these numbers, I'm going to multiply them together. I shouldn't do little, I'll just multiply, and I'm going to set up an equation and solve from here. So let me move all this up a little bit. My equation is going to look like this. I'm going to make my percentages into decimals. So 10% is going to become 0.1 times X, plus 45% is going to become 0.45 times 100 minus X. And then last, it's going to equal 0.25 times 100. Okay, I'm going to rewrite that over here so I can solve it out. That looks like an equation you can solve, right? There's decimals, but you can put all your x's together, you can put all your constants together, and we can solve from here. So I'll do this over here just so I have a little bit more space to work. And I'll just keep talking through my problem. So 0.1 x plus 0.4, plus 45. Distribute that 0.45 in, minus 0.45 x equals 25. Okay. I'm going to add those two together, so I get negative 0.35x, and I'm going to minus 45 from both sides to get negative 20. Sorry, I can write that a little bit nicer. All right, last I'm going to divide by that negative 0.35. Sometimes we get nice pretty numbers, sometimes we don't. Don't let that affect you. I'm going to say x equals I believe last year we got 57.1. Did anybody get that yet? $57.1. Perfect. Okay. Awesome. Okay. Anybody questions on how I got X? Now I want to know what is X. What does this 57.1 mean? Right? Good. What's my units on this? Gallons, good. And we're gonna say gallons of, and I'm gonna say what percent solution it is. It's gallons of that 10% solution, okay? How much of the 45% solution do I have? $42.9? Yeah, mental math. I only know because I messed that up earlier today too, so. 42.9, and what did you do with that mental math, Megan? What were you doing in your head?
100 minus 57.
Perfect. We were doing 100 minus X, and we know our X was 57.1, so 100 minus that would be 42.9 gallons. So that is our final answer. That's not too bad, is that? Can we do another one just like that? Okay. Anybody questions before I move on to that? Okay. Okay. This next one says, the chemistry lab at the University of Hardwoods keeps 2 acidic solutions on hand. One is 20% acid and the other is 35% acid. How much 20% acid solution and how much 35% acid solution should be used to prepare 25 liters of a 26% acid solution? All right, draw your boxes. I like to do our percentages first. What percentage do I want to end with? What do I want by itself on the side of the equal sign? 26%. So then the other two can be wherever. I'll do 20% first, and then I'll do 35% second. Okay. Now I care about the amount. How much do I want to end with? What's the total amount I want at the end? 25 liters. Good. What should I put for the other two? X. And then what should I put an X with 20. You can put X with 35, it doesn't matter, but I put X with 20. Ryan, what comes next? 25 minus X, good. That's what you were gonna tell me, right? The answer, you didn't have a question? Ryan?
Yeah.
Yeah, Ava, you were gonna tell me the answer too? Okay, good, wanna make sure I'm not losing any questions. Okay, now I'm gonna multiply those out and I'm gonna solve. So I'll write my equation and then I'll go to the side and solve it. So 0.2x plus 0.35 times 25 minus x equals 0.26 times 25. Am I moving too fast or are we doing okay? I'm gonna take that as we're doing okay. Good, do your solving on your own. All right, do you guys get x equals 15? What does that mean? What is that in reference to?
15 gallons or 15 liters, so that's 1%.
Good. And how much of the 35% do I have? We did 25 minus 15. Savings. All right, like I said, these are super important for the test, for your life. Just kidding, probably not for your life, but for the test. I'm not here to play around. All right, let's go up. Let's do G, and then I'll see if we can do C, and then if we have more time, we've got a couple other I'd be happy to do. But let's move up. Let's do letter G. Yeah.
Are you ever gonna do the problems like say you give us the answer and then you have one of the boxes and we have to calculate the other one, like you don't know like let's say for example like 15 was also like 20% and then you have to calculate out.
Oh,
Or are we always just gonna do it when we're finding like that one solution?
I want you to tell me what both of them are. If I'm understanding your question correctly, sometimes I might tell you that like I'm gonna do like 25 liters of like this 35% one, and we don't know how much 20%. And then my question to you would be, how much would I end up with? So how much, if I know that I've got X amount of 20%, 25 liters of my other, how much am I gonna end with? Anyone know? What expression would I write down here, Ryan? Plus X, yeah. So we would add them together to get that final amount. So I could ask something like that. And so in that one, I may ask, what's the total amount at the end? Then you'll just have to take whatever the X you found and add 25 or however much is to that. Yeah, of course. Let me go back and make sure this is correct. Else we get confused later. Okay. All right, let's look at letter G. This one actually might be more realistic than some of these other ones we're talking about, because one day you guys are going to get jobs, and some of you might work in sales. This says Ruth is weighing 2 job offers from the sales department of 2 competing companies. One offers a base salary of $25,000 plus 5% of gross sales. The other offers a base salary of $20,000 plus 7% of gross sales. So what happens there is she's paid $25,000 no matter what, but then however much she sells, she gets 5% of that added to her paycheck. The other one, she's paid a little bit less, but she gets to keep 7% of what she sells. So what we're kind of asking is, how much does she need to sell in order for the second job to be the better job offer? Okay, so we're going to write an equation. We're going to kind of put these guys toe to toe. We're going to have company 1 on one side. We're going to say that should equal company 2. And I want to know when they equal each other, because the minute they equal each other, if she makes more sales than that, we're going to say that the second one is the better deal. Okay. Does anyone think they can write an equation to represent what the first company is going to pay her? Ava, what do you think?
Would it be 0.05x plus 25,000?
Good. Why is the X with the 5%, not the 25,000?
Because it's gonna go on with the percentage.
Yes.
The percentage.
Okay.
Sorry, no.
That's okay. Quinn, you want to add on to that, or are you good?
I was just gonna say that X is kind of like, just depends on how much you sell.
Yeah, X is how much she sells. The 25,000 she's going to make regardless, but it's at 5%. We don't know how much that's going to be depending on how much she sells. All right, how am I going to write an equation for the other one? Yeah, Ava, finish it.
0.07x plus 20,000.
Good. And now we're just going to solve this. This is, again, decimals, but we can easily solve that. Get all the variables to one side, get the other numbers to the other side, and then we'll solve. So I'm going to minus 0.05x from both sides. I'm going to minus 20,000 from both sides. I think I've got too many zeros in this 25,000. There we go, that was better. So I get 5,000 equals 0.02x. Then I can divide by 0.02, and x will equal 250,000. So she has to sell $250,000 worth of whatever she's selling in order for the second job to be the better job offer. The funny thing we were talking about last period is we're like, that could be really easy or really hard depending on what you're selling. If you're selling houses, you can sell a $25,000 house pretty easily, and then you'd start making more. But if you're selling something like small, like a magazine, selling $250,000 worth of magazines would probably take like a lot longer. So it's one of those things that you'd have to kind of weigh out, like how good at sales are you? What's the probability you'll get this much, if not more than that, in order to take which job over the other. Okay, cool. All right, if we can do letter C, that would be great. This one says 17. It says the base of an isosceles triangle is half as long as the two equal sides. Write the area of the triangle as a function of the length of the base. Okay. So we are going to draw this triangle. Isosceles triangle, what does that mean to you?
Two sides.
Two sides. Only two sides are equal. And I know it says write it in terms of the base. I want to write it in terms of the sides. I think that's a little bit harder, and that's why I want to kind of challenge us to do it that way. Let's label these sides X. The base, it just told us the base is, what did it say? The base is half as long as the two equal sides. So the base is what in terms of X? It's 1/2 of the length of those sides. 1/2 X. Good. Okay. Now, we have to write the area of a triangle. Does anyone remember what the area of a triangle is? 1/2 base times height. Okay. I do already have base. We're doing good there. But I need height. Height comes from the fact that we have to drop an altitude. I have to drop an altitude, a line from the top point to a line that's perpendicular on my triangle. And now I get a smaller little right triangle out of it. Let's label these sides. We know this long side is X. How much is this little part on the bottom going to be? Andrew? No. I don't know that. I know that you're going back to your special right triangles. I don't know that for sure. I can think of a better way of saying it. If this side is X and the base is 1/2 X, what should the bottom be? If the bottom is 1/2 X, what's half of 1/2 X? Okay, good. You guys are really stressing me out. 1/4 X. And then I'm going to label this other side as height. We can set up Pythagorean theorem to get h in terms of x, and then I can plug that in for my h. I know I'm running short on time, but let me hang in for 1 second. The one thing that is confusing though, h we normally have as our hypotenuse. This time it references my height, so it's just your a or b. So I'm going to do h squared plus 1/4 x squared equals x squared. When we square our 1/4 x, we get 1/16 x squared equals x squared. And then you can get h by itself. I'll finish for the sake of the video. You are responsible for knowing this if you're leaving though. When I see you next, it's 1.7 is due. Okay, so for the sake of the video, I'm just finishing this one. And then minus that 1.116 x squared from both sides. Now 1x squared minus 1/16 x squared, that becomes the same thing as 16/16. And 16 minus 1 is going to be 15/16 x squared. Square root both sides. H equals √15/4x. And then we plug that guy into there. Thank you. Thank you. And once I take this and plug it in, I get 1/2 times the base, which is 1/2 x, times √15/4 times x. And then we can do my tops together. Root 15, x times x is x squared. And then 2 times 2 times 4 is 16. And that is my final answer. Bye. So I know that was a lot of work, but we were so close to the end, I just wanted to finish that.
Should we have the review guide done by Monday?
No. Just on test day. Reviews always do on test day, but I do want your 1-7 homework due next class.